Not as bad as sociology or psychology, but it is still about people, behavior of people. Now, uh, who comes up with these numbers, cash flows? The people who are proponents of this project. I'm an engineer in NVIDIA. Think of yourself at 2019, and I want to put these as what NVIDIA GPUs are essentially. They are supercomputers in a small box. Do you guys know what I mean by a supercomputer? It's basically, I mean, until about 20 years ago, these computers had only one processor. So when it was making calculations, calculations were made one at a time and put together. For example, my PC right now has 32 processors. So if I ask Excel to calculate present value of 320,000 numbers, it actually, there's a motherboard, I call it the mother, and that mother has 32 child laborers, okay? Think of yourself in somewhere in China. And mother says, here's your task. You're going to go ahead and calculate 10,000 of these and report them back to me. Then mother puts all of those together, which means something that took 32 seconds 20 years ago using the same chip speed and stuff now takes only 1 second. What those NVIDIA GPUs are, they are massively parallel processing units. There are thousands and thousands and thousands of them, and you can also put all of them together. That's why these data center calculations, which are based on machine learning and a lot of data, some of these models use billions of observations. What they're doing are effectively complicated forms of linear regression. But every time you do these, they are nonlinear, but in each iteration, you act as if it's linear. You have to emerge, let's say you have 1 million variables. The number of calculations you have to make to solve a system of 1 million equations increases by the square of number of variables. So if I go from 1,000 variable to 1 million variable, my workload increases by a factor of million, not by a factor of 1,000. So 20 years ago, unless you had supercomputers, which were effectively massively parallel computing environments, you couldn't do it. Now you can. That's where the power of these things come. Unfortunately, they use so much heat. So we're waiting for the quantum computers to be fully developed. Then, that thing that took only 1 second probably is going to take 1 microsecond, not millisecond, micro, which is 1 millionth of a second. I mean, there were way back when I started my first PhD program in economics. I was mostly interested in econometrics. I had to come up with a new way of modeling certain stuff, but the damn thing was so bad. Normally, you maximize or minimize certain function to make these calculations, and it helps if the function is continuous or differentiable. In fact, most of the machinery is based on that. My objective function, not only it wasn't differentiable, the damn thing wasn't even continuous. And I had to develop new methods. And to do it right, it took hours and hours and days. So I told my advisor, I'm going to do an approximate method and iterate on that. He said, sure. Then at that time, these were mainframes. Boston College had a 32-bit mainframe. PCs were only 16-bit at the time. And suddenly they said, oh, the company Digital, they came up with a 64-bit chip, the Alpha chip. I mean, we use 64-bit now, but I'm talking about 1993. And it came, my advisor, why don't you try that? And I tried the exact same calculations. The stuff that took me 10 days to calculate were happening in 1 hour. My advisor says, now you have to do the exact one. That may be one reason why I ended up never finishing that PhD, because I ended up getting married and getting a job and was foolish enough to think that I can actually finish my PhD while working full time and having a wife. No, thank you. That is not possible. At least it wasn't possible for me. It's one of those impossible to theorems in economics. So human beings come into the picture. I'm these NVIDIA engineers. I want my new chip design to be approved, right? Of course, without even going into any fraud, we do the analysis. And especially in projects like these, most of the cash flow ends up coming in the later end. Because the first few years you develop demand, you may even lose some money, but eventually you make money. We kind of see it from NVIDIA. I mean, they made back 5 years ago, NVIDIA may have had even negative cash or close to it. Now they have crap loads of cash and it just keeps going up. Why? Because a lot of the cash flow started coming after 5 years. The trouble with that is, even with the without the built-in bias of the project proponents, there is a law of physics called second law of thermodynamics. It's just a fancy way of saying the uncertainty associated with projecting or forecasting into the future increases with your span of forecast. So let's say I put a gun to your head and I said, you're going to take one of these bets. I have the first year forecast, $100. I have the fifth year forecast, $100. And the bets are I give you $100 if the forecast is within plus or minus $10. The actualization is within plus or minus $10 of the forecast. Uh, Same thing in the fifth year. And I said, you got to pick one of these bets. If it's outside that, you get zero. Okay? Or I take your money. Even worse. So which bet would you pick? The bet that first year forecast is going to be within plus or minus, or the fifth year forecast? This is somewhat of a rhetorical question. Obviously, you would pick the first year. Why? A forecast is some sort of projection or statistical calculation you make based on the information you have right now. But within those 5 years, a lot of things can go wrong. The statistical forecast is the art of figuring out what would happen or what could happen if the future looks like the past. That's what forecasting is. For next year, future in terms of structure may be the same as past. 5 years from now, who knows? If 10 years ago, they told you that there would have been these GPUs, you would have looked at them, did you just come out of an asylum? I can actually solve a billion variable or trillion variable equations in those large language models. They would say, no, thank you. Put your aluminum tinfoil hat and go home. But now it's a reality. That's how the universe works. Entropy always increases. As time passes, uncertainty increases. That means most of the cash flow is coming from more uncertain stuff into the future. And if you are a proponent of the project, more than likely you see that uncertain future at a more optimistic light than other people would. It doesn't mean you're dishonest or you're committing fraud. It's just your inherent bias. Without even realizing you're biased, you may be biased. So we may have to use certain criteria to kind of discount that. Maybe one decision would be discount future cash flows at a little bit higher rates, but we do that at more advanced finance classes. But that wouldn't be MPV anymore, right? So we need to think about some other stuff. And two, there are certain things, especially for localized stuff. I don't want my office in Burkina Faso. For those of you who do not know, it is a country in West Central Africa. Its old name was Upper Volta. It is to the north of the River Volta. It used to be a French colony until 1960. I don't want my Burkina Faso office to make decisions about a 10-year project by themselves. But I don't want to be involved in it. I have no idea. I'm the CFO. I even have no idea what Burkina Faso is. I do because I come from a generation that didn't have Google Maps. We actually had atlases and we looked at stuff. At least some of us did. For example, have you guys heard of a country called Eswatini recently in the news? If you follow politics a little bit, you may have. Uh, U.S. now is sending some of those people that are going to deport. They can't send them back to their home country because of persecution or whatever.